Welcome to today's episode of Big Data and Brews. Today with Mike. Mike, can you introduce yourself and your brew?
I'm Mike Zeller, the CEO of Zementis. We focus on operational predictive analytics, and my brew here is Franziskaner Hefeweizen, very German.
Are you German?
I am German, and so this is the German episode of Big Data Brews, I think. So we'll try a summer-like beer, Hefeweizen, which is a yeast kind of a beer.
Yeah. It's a meal almost, right?
It's a meal, and you have to be careful how you pour it into your glass. That's the first test.
Okay.
So we'll try that one. And
well, let me open it. So you grew up in Bavaria?
I did, yes.
Okay. Yeah, well, I didn't. So I have no whatsoever Hefeweizen skills. So I will learn today.
Okay, we'll try it.
In fact, usually I don't drink Hefeweizen, so I will look at you and then I will try to make the same thing.
Okay, so
and of course we don't have the right glasses, right? So
yeah,
I apologize. We will fix that.
But next time. So important with the Hefeweizen is really that you tilt your glass and you pour it very slowly. Otherwise, all you get is a glass full of foam, and that's of course not what you want. And then at the end, before you pour everything, you kind of swish a little bit so you get the yeast.
Something on the ground.
The yeast at the bottom. So this is unfiltered. This is really the yeast, and you need that, as part of your beer to make it complete. So you can do that. Swish a little bit, and then
there's a whole technique to that. I usually just open and drink.
No, this is it takes its time, and then you pour it in. We'll finish it next time with the complete glass, the right glass. You
would give everything.
You get everything. So this is a little tricky now, but pretty good for now. So this is
I can drink off a little bit.
No. That's a no. So Hefeweizen, you always have to drink from a glass. So
all right.
This one.
Cheers. Welcome.
Yeah. Cheers. Prost. Yeah.
Yeah, I love my job. I just drink beer and talk to people.
That's a good start, yeah.
So, give us a little bit on your background and then on Zementis and more about your technology. But why don't we start with your background?
Yeah. So my background, don't hold it against me. I'm a physicist. So I studied machine learning, used it in robotics, vision processing, and kind of studying the machine learning algorithms and how the brain works. Yeah. So this is.
By the way, I think the most amazing architects and computer scientists never studied computer science. So if you go around, they all did it bioinformatics or biology. Our CTO is a biologist. So. A good friend of mine, Hans Doctor, who does Gradle build system, he's a physicist too. So I think that's a good sign. That's a good sign.
Yeah. So I think also kind of coming from different backgrounds gives you the ability to kind of combine different technologies. Interdisciplinary research, I think, is very important. Yeah. So here we have machine learning. How does biology do it? How does our brain do it? Translate it into math. Algorithms, and what we do with Zementis is really deployment of predictive models. So it's kind of back to my roots. Making it easier to operationalize predictive analytics. So taking those advanced models, deploy them very easily, kind of mainstream operational systems like in a business process, in a database system, in Hadoop, really making it super easy for anyone to utilize those models. Because I think that's the key aspect of big data, big data brews, right? So the key aspect of big data is using it to make better decisions, and predictive analytics is really a great example for that.
Before we go more into your technology, give us a little bit of the history of the company, how you guys got together. When did you start it? Did you start it in Germany or?
No, we started it here in San Diego. San Diego is actually a very
twist my arm, San Diego.
It's not the worst place in the world, and it's actually a very good place for predictive analytics. So it's kind of a hotbed of analytics companies.
Interesting.
So we started there with a core team that came from different backgrounds: software engineering, machine learning.
A few surfers.
Actually, I don't think we have surfers.
Yeah. I would think in San Diego there's a lot of surfers, no?
There are, yeah, but we're too serious probably as a crowd. So we actually started in 2004, so quite some time ago, with an exclusive footprint in the financial industry.
Okay.
Which for a while wasn't the best industry to work in, but we since diversified quite a bit. So coming from that background, we built a scoring engine, so to speak, that allows you to deploy predictive models.
And did you work in the financial service industry before? Or you just said, okay, I want to do this? How did it happen?
Yeah, good question. It was actually a consulting engagement I had in the financial industry. So I was consulting for different companies, and it really presented itself the opportunity to introduce them to advanced machine learning algorithms. And so this was kind of the ignition of the company, where it allowed us to start out with clients from day one, which is a very fortunate opportunity.
Yeah, I think a lot of really great companies started this way, like ClickTech or others, right, where they first really worked in the industry, had all this experience, and then they basically productionalized their learnings, and they didn't have to hold their finger onto the wind and see what kind of product to build, because they kind of did it a few times.
Yeah, we kind of felt the pain. So we were initially building predictive models, and then we had the need to deploy them, and it was very, very painful. Always custom code, a lot of work involved, always one-offs, and that really gave us the idea for the products that we have today.
So let's talk a little bit about the product. I mean, what is the product doing? Where are the borders? Where do you need other tools? Where is it integrated with things? But, let's say I don't want to say I'm a data scientist because I don't believe in that. Anyhow, let's say I'm a business analyst and I, want to do some, I don't know, loan scoring, or maybe is that a good use case? What's kind of the hello world for
predictive fraud detection?
Yeah. Okay. Let's score. Yeah. Why don't we I happen to have 100 trillion credit card transaction. How do I deal with that? So help me. Where's your tool sitting? Where are others coming in? How do I make that happen?
Yeah. So there's always the two worlds that we face. One is the data scientist or the machine learning expert that really builds advanced models that predict risk, predict fraud, predict upsell and cross-sell opportunities.
And how do they build this? Is it do they write code or?
In various different tools typically. Okay. So we have a great selection of commercial open source tools, commercial like SAS, SPSS, KXCN, open source like R, NIME, RapidMiner, a lot of tools for data mining scientists to build models.
Yeah, okay.
But once you have that model, that's where we start really with our tools, is how do you operationalize them? How do you really run them through a scalable 100 million, billion transactions?
So a RapidMiner or an SPSS is more kind of a design environment where I build something, and then where do I run it? So you maybe are the application server for predictive models?
You could think about that, yeah. Think of it, the scoring engine, the application server, the deployment shell, so to speak, where you plug in one or many models to apply them in whatever your most favorite data mining operational environment is actually.
So how do they communicate? If I build something in SPSS or RapidMiner, do I give you some Python code, or what's the?
So what we use is an open standard called PMML, the Predictive Model Markup Language. The idea really is
sounds like XML.
It's an XML representation of your model, and the idea is not to move code. So not to move custom code from the data science desktop into your operational IT environment. Very complex, very hard to keep track of and to QA. So the idea is to have a common standard, PMML, an XML representation of your model that I can consume, that I can first of all export from all data mining tools, commercial or open source, and then consume in our engine and then deploy on various different platforms.
So just so I get this right, so I built something in RapidMiner, SPSS, or whatever it might be, then I export it to PMML, and now I have 100 trillion records over here in a database on a Hadoop system. So what do I do now?
Now you apply that model on your data. And
your engine is where this is executed.
Exactly. Yes.
So, and then do you integrate your engine into Hadoop, or what are the different areas there?
Hadoop is one option. So the idea really is to to have many different choices for your platform. So Hadoop is one, through DataMir, through Hive. In database, the classical data warehouse. So we run on top of Netezza, on Greenplum, Teradata, and Sybase IQ. So it really depends on the customer's current IT infrastructure to make it easy to deploy it. And you pick the right environments. So we have real-time environments that are kind of standalone. They can run in the cloud. So we also have a cloud-based solution on Amazon.
Is people using this? We see people not so happily pushing data to the cloud. What's your experience?
It depends. So there's quite a few use cases, but if you're looking at
it's the banks moving credit card transaction into the cloud?
Not really. So I mean that industry. So whenever you have a regulatory environment, the cloud most often is not the choice.
Okay.
But for proof of concepts, for smaller consulting firms, for marketing applications, there are many use cases that you can really use in the cloud, where it's not personally identifiable information,
right?
And it's a pass through. You don't necessarily have to store your data in the cloud. So but we also have clients that have their data already in the cloud, so there's no questions are asked. But regulatory environments or the government typically goes in-house, of course. So I think it's really about simplicity right there and the choice of the customer to deploy predictive models wherever they need to go, not having to worry about it.
So you said predictive models. That basically mean you're really limited to models you learn or you build and then you execute, right? So there's no... Is there classification?
There's classification, there's...
but not clustering.
There's clustering capabilities, So you can apply cluster models, classification models. It's really across the mainstream, what I would call predictive models, from linear and logistic regression to the machine learning algorithms like neural networks, support vector machines, all the way to ensemble models, what was used, for example, in the Netflix prize. So again, the most complex models, and the more complex they are, the easier it is to move them from the data mining scientist to your operational environment using a standard, not custom code.
Right, and that would be PMML and Zementis running that. So you wrote your product is written in C++ then to be super fast?
No, actually our product is in Java.
Oh, I like Java. That's good.
I think there's not much of a difference there, and the benefit with Java you get is you don't have to recompile on every different platform, and you can run really across different target platforms, and that really has enabled us to spread across our partnerships very quickly.
And what would you say if I'm the tech guy that says, well, but Java is super slow?
It's not as slow as it used to be. It is much faster, and I think the differences are marginal, and the benefits you get from not being tied to a very specific compiled code on a certain platform are just outweighing a small increase in speed you could get.
Hardware isn't that expensive anymore. So let's come a little bit to the use cases. What do you see as kind of the main use case in your customer base? So maybe let's even move one step back. What are the verticals you guys seeing, and then are there specific use cases in those verticals?
Yeah, so verticals this is a platform application, same as your data warehouse, your Hadoop system would be across all industry verticals, and that's what our customers span, from consumer electronics to telecom, financial industry to government.
It's very diverse.
It's very diverse. It's really a true platform application. Sometimes difficult to be able to serve all these different verticals because you have to speak the language to a certain extent. But if you think about predictive models, they're the same mathematical models, the same algorithms that you use everywhere. So the scoring of one model in marketing is the same as a similar algorithm in the financial industry. So that makes it really a very universal application. That's the fun part of it. You can play anywhere you want to go.
And what are there any main, where you say, oh, yeah, this is just blueprinted, we do this all the time?
Yeah.
Besides, you sounded like credit card.
Yeah, fraud detection in general has been kind of the marquee use case of advanced predictive analytics. I think the financial industry is ahead of the curve in adopting predictive analytics, but we see a lot of marketing applications, cross-sell, upsell, churn prediction in the telecom industry. Those are, I think, the classical mainstream use cases. You see a lot of machine predictive maintenance and quality control use cases now that sensors are becoming so cheap. And I think we're at this very interesting point in time where processing power becomes very affordable, cheap. Yeah. Storage, so massive amounts of data you can keep around, you can move around, you can work with it. Yeah. The algorithms are well known, so it's really us creating business value out of that. I mean, it's really a very interesting point in time where things that what we did in research 10, 20 years ago, very hard, very complicated on dedicated clusters, now you can do really standards-based and very easy on everybody's desktop.
I want to drill down in more of those use cases because they're so much fun, right? So you said predictive services. What would be the example? You predict when my car needs to get new brakes, or what's the most fun one you can share?
For example, you could look at vibration signatures of rotating equipment. Let's pick one.
Rotating equipment.
Yeah, rotating equipment like vacuum pumps, something that rotates very, very quickly.
Okay.
And
that's interesting.
And vacuum pumps, for example, are used in many semiconductor processes, and there's lots and lots of vacuum pumps. So having those fail is very bad for the overall process. So you'd like to know in advance, when those elements may be about to fail. Yeah. Similar exciting use case in the energy grid. You'd like to look at all your transformers in the field, look at voltages, currents, temperatures. They all have sensors in it, so you can detect when there's something wrong with the equipment, and not necessarily send a maintenance crew out there on a quarterly interval just to check on it, but really be just more predictive and more dedicated, and so we can do more with less resources.
So is that that you would learn the model then, or I mean, how is that? So you execute the model, but how are people coming up with those dimensions? They're like this sensor, that temperature, that. Yeah. Is that where the data scientists come into play? Or?
Exactly. That's kind of the offline process. You always have a learning and a data exploration process where you look at your data, you look at outliers, you look at different variables, what you have, what you can do, and then you build your model. Kind of the scientific aspect of the process. And then our products almost sit at the tail end of that, where it becomes a repeatable process. Now you have that model, but you want to execute it every time you get a sensor reading. So in real time potentially, or you have a nightly batch run where you run through 100 million transactions. Again, it's where repeatability is very important, and being able to crunch and apply those models over and over again.
So how is Zementis then deployed? What's kind of the infrastructure, the moving pieces? And where is it running on? Maybe you can make a little drawing, and how is it all working together?
Yeah, let me show you that part. So if you start with a data scientist, we often have like R, for example, or we have SPSS or SAS models, right? So here you would have, I can do a little stick figure maybe for the data scientist.
Hey, he needs a crown, because it's the new king in the data world, right?
Okay, we got the crown going. And a big brain. So I mean, this is really the art form, exploring data, building models, and this is the most complex part of it. You have data, you're trying to explore it, you build a certain model. And then on the other extreme, you have your different database platforms, for example. So you have database platforms, you have maybe Hadoop next to it, or you have something like real-time or cloud. Let's do cloud maybe, just different platforms.
And then what databases do you guys support? Or run in or run off? Or
Yeah, so typically your data warehouse appliances that are massively parallel, similar to Hadoop, but more structured in
like
in
in
its approach.
Netezza?
Yeah, so you have Netezza, you have Teradata, Aster, Greenplum, Sybase IQ,
And you guys integrate with all of them?
yes, we integrate with all of them.
That's really cool.
So the fun part is that here you can leverage kind of the existing infrastructure, like on massively parallel execution. So you have many nodes on the database, on the data warehouse. You have many nodes on the Hadoop platform, where we integrate with Datamere, of course, and then Hive. And on the cloud, you can have many different servers serving requests. Well, this is more of a real-time application then. So you have different target platforms that you can deploy your models to. So the glue in between is really the standard that we use, PMML.
Yeah.
I mean that's the key aspect of it. PMML.
Is that an ISO standard, or what is that?
It's an industry standard, so
Okay.
it is really
Okay.
developed by vendors. So
Okay.
it's driven by vendors. R
Yeah.
is of course an open source tool, but SPSS, SAS, all the big guys are part of that. SPSS now, of course, being part of IBM. But the idea is to move models that you develop on the left side very seamlessly over to the right side, and not being locked into a single vendor, not being locked into a single platform. So
Right.
you can take your choices here, find the best data scientist you can find,
Right.
not necessarily
Free
limiting,
of tool choice, yeah.
free of tool choice, or pick you build your decision tree in R, you build your neural network in SPSS, take your choices, and then combine all of those models onto your operational platform. So
Is it common that people run then multiple models after each other, kind of stream the data through different models? Is that a use
not
case?
necessarily.
Okay.
It's an option, but you would run maybe in parallel. You would say what model performs
I see.
better.
Okay.
You can compare, but most often you have dedicated models for different tasks, or ensemble models that work together.
So we just talked to a customer, and their biggest problem is like, how do you really manage those models? I guess since PMML is XML, do you check them into a versioning system, or are there any cool, good tools to kind of manage the the life cycle of predictive models? Is that something you do?
We don't manage the life cycle per se. We allow you to deploy one or many models in our engines that sit on the different host platforms. But what you can do with, since it's XML, you can basically check it into your source code control and manage it just the same way. And often that's what the client choose because they already have code control, source code control. And you have many tools on the data mining scientist side. So the commonality really is an underlying IT process where you manage the deployment of models as part of your infrastructure.
And then when I run my model, my data through the model that is executed in the Zementis engine, I basically get, I generate data, right? I get like a score or like a decision.
Yeah.
Okay, so then I can deal with it myself, put it in another table, or update a record, or write a new sequence file, I guess, yeah?
Yes, exactly. So you would write it into your database, into your Hadoop file system, or you would integrate it into your business process through a web services call, for example. So the idea really is to go from data to a smarter decision as easy as possible, as fast as possible.
And then, so that was an interesting one. Integrate in your process, in your business process. Would I use Zementis if, for example, I sign up for a home insurance or a home loan or something, or maybe healthcare insurance, and then would my data be sent to Zementis in the cloud or on an application server, and then it comes back and says, not approved?
Yeah, so clients integrate it that way, but for sensitive information, it typically is deployed in-house as part of their custom solution.
Right.
Their most trusted data center. It depends on the use case scenario.
But so it's not just batch operation; it's also interactive, where I sign up on a website and I instantly get kind of like
Yeah.
Okay.
And the cool part is really you don't have to know this when you build a model. You know, I can score everybody that I have in my population, all of my 100 million
At
customers.
once, or you do it interactively.
Or I can do it interactively. So you have either big data or small data, which, you know, in the case of small data, often latency is important. So fast data.
Right.
So instead of doing 100 million, massively parallel, you just do one single transaction, but in 10 milliseconds.
Yeah. Okay. Well, so I basically can use whatever platform I want to on both sides, on design and execution side.
Exactly.
That's helpful. Well, let's make a short break here. Well, for you guys, it will take a week, but we will just have another beer, and then we see you back in the next episode of Big Data on Brews.